Load forecasting for electric utilities is a crucial step in planning and operations, especially with the increasingly stressed utilization of equipment. Our project is focused on predicting, comparing future power consumptions results using multiple machine learning algorithms like linear regression, support vector regression, and optimizing it using stochastic gradient descent. We compared these various machine learning algorithms and focused on coming up with a suitable algorithm from our dataset. To make it easy for the end user, we are using Kenta GUI. The data was notably treated to remove problematic events for training such as outages and to fit sudden jumps in load.
Talking about the dataset, we obtained a dataset from UCD's database. Our dataset belongs to CER, that is Commission of Energy Regulation. The Commission for Energy Regulation is the regulator for electricity and natural gas sector in Ireland. The CER was first set up in 1999 and works within the framework of national and EU energy policy, which aims to create a single European electricity market that best meets the needs of Europe's energy consumers. Our dataset consisted of meter ID. It further consisted of a string having date and time and energy consumed in kilowatts. We extracted a string having date and time and divided it into 4 fields, that is day, month, year and time. Our dataset is obtained from 3,000 Irish households and it dates back to 2009. Now through this project, if we install smart meters in our university, then through our work we would be able to predict future power consumption with the increase in students per year. This would be really beneficial for our university.
Now let us talk about linear regression, which is a mathematical model used in machine learning to predict a variable based on input variables, also known as features. There are 2 types of linear regression, single variable and multivariable. Today we will talk about single variable linear regression. So for example, we need to predict the price of a house based on its size. Now imagine we have this data set. These points correspond to a price of the house based on its size. So our objective is to find a line that fits these data points with minimum error. For example, this line becomes a prediction, which is also known as hypothesis and is denoted by hx. Now, to find the errors, what we do is take the hypothesis function, which is this, minimize it minus this point, which gives us this error. We do this for all the points. Take the sum I equal to 1 to m, where m is the number of data points in this set. Take the average 1 upon m. Square this, we need to find the square error, and put a 2 here, which is used for minimization. Now this is our cost function. Our objective is to minimize this cost function, which minimizes the errors, and we get this line. The minimization is done using gradient descent. And we'll talk about that later. And we add the 0 for simplification when we do gradient descent.
We minimize the cost function using gradient descent. To understand this algorithm, I want you to imagine a hill, and I want you to imagine that you are physically standing at a high point on the hill. In gradient descent, what we're going to do is we're going to look in all directions around us and ask, how do we get downhill fast? Turns out that the best direction is to take a little step downhill. Okay, and now you're at this new point on your hill. You're gonna again look all around you and say, what direction should I step in order to take a little baby step downhill? And if you do that and take another step, and you take another step in the downward direction, and then you keep going. From this new point, you look around again and decide what direction would take you downhill most quickly, and take another step and continue doing so until you reach the local minimum.
Through this project, we learned multiple learning algorithms. We compared the performance of multiple machine learning algorithms such as linear regression and support vector regression. In the future, we also plan to try other algorithms and measure their performance. There's one more thing, installing smart meters in a campus would be really beneficial as it would make it easier for us to predict the future consumption of electricity.